WVEC-TV, plan.
Here we go.
This is Jeff Petray, ABC News.
Pre-liftoff water will be released at T-minus 16 seconds. And we have a go for auto sequence start. Discovery's 4 redundant computers have primary control of critical vehicle function. 6, 5, 4, 3, 2, 1. We have booster ignition and liftoff.
Beyond the Frontiers of Flight is brought to you by your new Dodge dealers. We know how to help. And by Jefferson National Bank, keeping the trust Virginians have placed in us.
From early airplanes to hypersonic spacecraft, to the moon and Mars, to the space station, technology spin-offs and environmental breakthroughs, this is the story of the NASA Langley Research Center and the men and women of Langley who have made America a leader in air and space for nearly 8 decades. Kitty Hawk, 1903, the dawn of flight. The success of the Wright brothers put America in the forefront of aviation. By World War I, however, it had become clear that this edge had been lost to German, British, and French aviation advances. As a response, Congress created the Advisory Committee for Aeronautics, the predecessor of NASA. Its mission, to regain the air superiority yielded to Europe during the war. This would require new technology and a research laboratory to find practical solutions to the problems of flight. A site was selected in Hampton, Virginia, and today it's known as the NASA Langley Research Center, the nation's first civilian aeronautical laboratory. U.S. Representative George Brown of California is chairman of the House Committee on Science, Space, and Technology.
Langley has been central to the development of major new developments in aviation since it was founded 75 years ago, and therefore deserves a lot of the credit for the economic success of the aviation industry.
Langley has played a key role in virtually all of America's early advances in military and civil aviation, beginning with fundamental aeronautical research in the 1920s and 30s. Langley established an international reputation as the world's premier aeronautical laboratory, paving the way for later advances into space. Langley's first and second generation of researchers were young and inexperienced.
They just did not know that there were lots of things that couldn't be done, so they went ahead and did them anyway.
Langley's early engineers were enthusiasts for anything that would fly. The heart of their research was the wind tunnel, the fundamental tool for understanding flight. By the end of the 20s, Langley's complex of wind tunnels outperformed any other collection of facilities anywhere in the world. Thanks to such sophisticated equipment at Langley, American aircraft began to dominate the world's airways. In the late 20s and 30s, new types of airplanes emerged from technology created at Langley. Wood and fabric were replaced by metal. Engines became lighter and more powerful, were covered by a cowling and moved forward on the wing. As the airplane changed, Langley changed with it. During the Second World War, Langley engineers found ways to reduce wind drag on combat aircraft. This meant pilots could fly faster and farther, a big factor in the Allied victory in the air. After the war, researchers at Langley penetrated the high-speed frontier, enabling aircraft to reach supersonic speeds. Langley played essential roles in the development of several high-speed research airplanes, including Bell's X-1, the first plane to break the sound barrier. John Becker helped to make the X-15 the first winged aircraft designed to fly into space.
We did that in the X-15 in a limited way by designing it to fly out of the atmosphere for a few minutes of space flight, and then making a re-entry in the manner of the shuttle and a glide landing.
In 1958, the NACA changed into the National Aeronautics and Space Administration, NASA. Langley became officially known as the NASA Langley Research Center. Its mission remained constant: to expand the country's knowledge and capability in aeronautics and make America first in the race for space. In the early 1960s, Langley helped give birth to the space age.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
To the American public, NASA scientists and engineers were commonly viewed as high-tech heroes. Confidence was high, but the race for space was a daring gamble. Project Mercury, the nation's inaugural man-in-space program, was conceived and led by Langley's Space Task Group. This group led the original 7 Mercury astronauts through critical phases of their space flight training at Langley. Mercury demonstrated that men could be launched into space and safely returned. Langley continued to make contributions to the space effort, including its successful Scout Launch Vehicle program, Mercury, Gemini, Apollo, and Skylab manned programs. After Apollo came Viking, which in many ways matched and even surpassed the lunar landing program. NASA Langley helped to send 2 orbiters and 2 landers in the mid-1970s to the planet Mars, one of NASA's most difficult space projects ever undertaken.
In some respects, even more difficult than the manned lunar landings.
Langley became deeply involved in the development and testing of NASA's space shuttle. At Langley, the shuttle was put through thousands of hours of wind tunnel testing and other rigorous experiments. Langley was also responsible for optimizing the design of the ceramic tiles that protects the shuttle from the intense heat of re-entry.
Together, these people thought they could do almost anything. And when you think about it, they almost did.
Jack Reeder, retired engineering pilot, is one of those people at Langley who could do almost anything. Over Reeder's distinguished 40-year career, he flew more than 200 types of aircraft, helped develop the P-51 Mustang fighter, and the first vertical takeoff and landing jets. He was recently inducted, along with Charles Lindbergh, into the Aviation Hall of Fame. Jack Reeder initiated a number of major aeronautics research efforts that continue today, like turning this 737 into a flying laboratory for NASA. Passing along the benefit of many decades of their renowned research to tomorrow's aerospace engineers are a distinguished group of retired Langley researchers. They're helping a group of high school students achieve entry into the Guinness Book of World Records for building the world's longest flying paper airplane. They more than accomplish their goal, and also inspire young people to keep the United States first in aeronautics and space. When we return, planes that will usher in a new era of air and space travel. Three decades ago, a British-French consortium initiated the Concorde program. Today, the Concorde is considered unfriendly to the environment and not an economic success. Industry projections say that around the turn of the century, the market, especially to the Pacific Rim, will support the launch of a second-generation supersonic airplane, the high-speed civil transport. NASA's Langley Research Center will lead a multi-year research program to develop technology for this future high-speed civil transport. At stake for the United States is an aircraft that could contribute up to 140,000 jobs and $200 billion to the national economy in the next century.
The return on investment in that area is far greater than any other government expenditures that I can think of. But that is typical. NASA has always been an investment in the future.
The United States today controls about 70% of the world's civil aviation market. That's down from 95% of that market in 1970, and could slip another 35% without the high-speed civil transport.
If we don't take the opportunity to put in place the technology to bring about the second generation of a supersonic transport, we will likely give up that opportunity to the Europeans. The market will unlikely support two such airplanes, a competitive European and U.S. airplane.
Langley's supercomputers will play a major role in the design of the high-speed civil transport. Fundamental to the current research effort is the basic assumption that this new generation of airplane will make use of existing airports, fly on conventional jet fuel, meet allowable standards of airport noise, have no harmful effects on the atmosphere, and be economically competitive with future long-haul subsonic airliners. Made from lightweight and very strong composite materials and exotic metal alloys, the high-speed civil transport should cut the travel time from Los Angeles to Tokyo from a current 10 hours to 4. The required investment in this technology is large, $4.5 billion, before industry is expected to start producing the plane. Another big-ticket, computer-intensive project at Langley is the National Aerospace Plane. This hypersonic craft is designed to take off from conventional runways, travel to low Earth orbit with passengers and freight, and then return for an airport landing. As conceived, the National Aerospace Plane could attain speeds of roughly 17,500 miles per hour, faster than a bullet. This plane represents the future in aeronautics technology. Langley is the lead NASA center for the National Aerospace Plane program and provides major technical support in several areas.
The National Aerospace Plane is an excellent example of the kind of thing that Langley does, and past, present, and future.
The National Aerospace Plane is a unique NASA Department of Defense initiative in cooperation with aerospace companies to design and develop the airframe, materials, and systems for the National Aerospace Plane, scheduled to begin flight in the late 1990s. When the National Aerospace Plane becomes a reality, it will harness a set of ramjets, scramjets, and finally rocket propulsion, flying directly into orbit. Creating such technologies present unique and even daunting challenges. No existing plane or wind tunnel can duplicate the 17,500 miles per hour the plane will attain. Computer models are being used to simulate the shock waves and heat that the National Aerospace Plane will encounter as it roars through Earth's atmosphere nearly 30 times faster than a jetliner. Materials being developed at Langley for the plane must meet rival needs of strength, lightness, and ability to withstand searing temperatures at re-entry. As daunting as the technical challenges facing the National Aerospace Plane program, as well as a high-speed civil transport project, are the funding hurdles that must be achieved in order to make these projects a reality.
For us to pass up the opportunities in advanced civil aviation would be the stupidest thing this country's ever done. It would be another example of where a technology that we developed and improved over a period of now close to 75 years, we would abdicate to some other country with less capacity, less capability, that had contributed less, merely because we failed to follow through with achieving the benefits that our investments have provided.
Coming up, breakthroughs in aeronautics that provide a better way to fly. Waiting for takeoff at Orlando International Airport, NASA's specially equipped 737 receives a report of heavy thunderstorms in the area. Bad news for most pilots, but a great day to fly for Langley's team of researchers. They're evaluating new systems that would warn pilots about approaching wind shear, strong, potentially hazardous currents of air from storms. Wind shear can literally knock a plane out of the sky on approach or landing. Between 1975 and 85, fully 50% of the aircraft fatalities were either directly or partially caused by this wind shear phenomenon. The Langley scientists actually fly the plane through storm cells where dangerous downdrafts are present. Once in place, detectors like those being tested in the NASA FAA wind shear sensors program should greatly enhance the safety of air travel throughout the world.
This program is directed at technology that will provide advance warning with ample time for pilots to avoid the affected area or escape from the encounter.
Congressman Brown has sometimes been credited as the father of wind shear avoidance for the role of his House committee in support of this research.
It's been successful. It's one of the really major research breakthroughs in aviation in the last few years, probably resulting in saving at least half the loss of life in the aviation industry, because about half of it was due to accidents resulting from wind shear.
Nassau Langley, in cooperation with Wilcox Electric, has also used its Research 737 aircraft to successfully demonstrate a sophisticated satellite-guided auto-land method. This technology could provide an inexpensive worldwide all-weather landing system for precision hands-off approach landings.
I wish I could do it that good.
Hey! That's the first
It
time
works.
I with a third different meat.
Encompassing a sprawling array of laboratories and test facilities, the Nassau Langley Research Center has never forgotten that the first A in NASA stood for aeronautics. Although its achievements in aeronautics have sometimes been overshadowed by the glories of spaceflight, Nassau Langley has not only maintained its historic position as a world leader in aeronautical research, it actually has built and improved upon it.
It's very clear that the present generation of aircraft would not have developed in the absence of the kind of research that Langley has been doing.
We played a primary role, and we intend to lead the way in the future for the next generation of aircraft.
Safety research at Langley's unique landing dynamics facility is running potentially life-saving tests designed to make safer takeoffs and landings for the nation's commercial and military aircraft, as well as a space shuttle fleet. A federal safety study reveals that during a recent 7-year period, 700 aircraft lost traction and ran off the runway. Langley is teaching the aviation industry how to improve aircraft safety in snow, ice, rain, and in the near future, even volcanic ash.
We can test tires, landing gears, and brake systems beyond their design limits without risking the flight crew of the airplane or bringing up the potential for damaging the airplane itself.
This F-06 Delta Dart jet used to be an Air Force fighter. It now has a new assignment at the Langley Research Center. The job of these Langley research pilots is to fly this sleek jet into thunderstorms to be struck by lightning, to learn about the dangers lightning poses to aircraft in flight. Numerous direct strikes have been monitored, and much has been learned that could enhance aircraft designs and flight safety in the future. Langley engineers are also using the F-106 with its highly swept wing to explore a design that incorporates a leading-edge flap. This wing design can increase the plane's performance by more than 20%, which may someday translate into better handling qualities for fighter aircraft, as well as improvements for high-speed transport.
Particularly in the approach and landing regime, where it will reduce drag and therefore require less thrust, and therefore produce less noise because the engines will be at lower power settings.
Better airplane wings is also the goal of another Langley research team. Using new construction techniques and tests with an oily crystal preparation, planes fly through the air easier because they are built with smoother, more aerodynamic surfaces. As a result, the aircraft burn less fuel, fly quieter, higher, and at faster speeds. In cooperation with the FAA and industry, Nassau Langley is developing advanced aeronautics concepts that will allow airline pilots to fly and land safely in very low visibility conditions, thereby increasing the number of flights in poor weather, reducing terminal delays, and cutting costs for the airline industry and the flying public. Enhanced vision technology could be available for retrofit on today's airliners before the end of the decade. For the farther-term supersonic transport application, pilots will likely have full-time synthetic vision through what can be called a virtual window, with no actual forward windows at all. This kind of synthetic vision helps to make the next-generation supersonic transport plane more competitive than its Concorde rival, which drops its nose in takeoffs and landings for pilot visibility. The U.S. aircraft would burn considerably less fuel because of its all-weather, all-sight takeoff and landing capability. Building on its heritage, NASA Langley's aeronautics research on high-performance aircraft has always been closely linked with industry and defense. The X-29 research attack aircraft has proven itself a test bed for new ideas, including computer-controlled flight systems and the use of composites in wing construction. The YF-22 is another example of a high-performance military fighter being developed upon a foundation of NASA Langley aerodynamics research. These highly successful flight programs will almost certainly influence future commercial and fighter aircraft, keeping the United States at the forefront of aviation.
The military's been the customer that supported a lot of the research that allowed the development of next-generation planes, which the civil aviation industry was then able to use to keep ahead of the rest of the world.
Next, expanding our future capabilities in space. With its tradition of research of winged flying vehicles and hypersonic space planes, it should be no surprise that the Langley Research Center has made vital contributions to NASA's Space Shuttle program. Much of the basic aerodynamic testing of the Space Shuttle was done in Langley's wind tunnels. Langley engineers continue to explore the performance of the shuttle. Among a number of program support activities, there has been a focus on further testing of the shuttle's landing and crew emergency escape systems and overall materials.
As soon as Shuttle got the authority to proceed, Langley changed its approach to look at what will replace Shuttle. And that's because that's our role. We're to look at the future.
To complement the Space Shuttle system and provide manned access to space for the next generation of space programs, Langley has conceived the HL-20 space taxi. The HL-20 was designed primarily to change crews on the space station Freedom.
You can think of it as the van that goes from the Kennedy Space Center up to Space Station and back, and just taking the crew and their carry-on luggage. There are some other potential missions, like satellite servicing, but the main mission is the transport of people at this time.
Langley, over the years, has continued to probe the many technical challenges of designing, building, and operating an effective multi-purpose laboratory in space. Today, this involvement includes substantial work in support of NASA's plans for Space Station Freedom. There remains much to learn about the unique environment of space. How do materials and coatings react to near-constant bombardment by solar radiation or collision with extraterrestrial debris like micrometeoroids? Do people and living things fare well or poorly in almost total weightlessness? How do temperature extremes affect organisms and structures? The Langley Research Center designed and built the Long-Duration Exposure Facility to begin to answer such questions. The bus-sized satellite carried 57 experiments into low Earth orbit for 6 years. On board were more than 10,000 items to test the effects of long-term space exposure, including more than 12 million tomato seeds, most of which later produced normal fruit in student science projects around the country.
Technologically, what will come out of LDEF is a set of handbooks which will be the Bible for how spacecraft are built for the next 20 or 30 years.
The space station is the next logical development in the human use of space. So if you believe that there is a future in space, as I do, then we need both the the ability to transport human beings into space, which currently is done with the space shuttle. And then we need an environment in which they can live and to do research in space.
Microgravity research gives America a competitive edge in today's high-tech global marketplace. It provides valuable breakthroughs in materials, electronics, and biosciences. For example, protein crystals can be grown larger and more uniform in space. Researchers want to tap the molecular structure of proteins, large molecules that perform many key functions in our bodies, so they can design drugs targeting specific diseases and viruses. Freedom's laboratory will house more than 100 instruments to develop better alloys, more efficient semiconductors, and solar energy systems. This research on Freedom is expected to revolutionize our way of life in the same way the Apollo era gave us technology for computers, laser surgery, long-distance calling, and even ATM machines. Already, prototype components are being built and tested. Engineers are also fine-tuning power systems and simulating the station's demands on electricity. 18 shuttle missions will carry prefabricated sections of the space station into orbit, using robotic arms to assist astronauts during assembly. Once completed, the laboratory and living space will be shared by the United States and its international partners, Canada, Japan, Russia, and 13 European countries. Freedom's 4-person crews will spend 3 to 6 months at a time living and working in this unique place above the Earth. The shuttle and HL-20 space taxi will regularly visit the station, carrying personnel, food, supplies, and new scientific experiments from Earth. Assembling Space Station Freedom will benefit from Langley's research on a program called Controlled Structures Interaction. It's designed to reduce the wobbling and settling motion of objects in space, thereby helping to bring bold visions for space research aboard Freedom closer to reality. When we return, a high-tech picture of the global climate. The beautiful island of Bermuda, unique among the world's islands in that it is relatively flat. This means the cloud cover in Bermuda is the same as in the ocean surrounding it. This is why Charles Whitlock and his colleagues from NASA's Langley Research Center are here. They're conducting the first global surface radiation budget experiment to determine if satellites have been giving an accurate picture of the global climate. The experiments to measure the height of ocean clouds are a part of NASA's World Climate Research Program. One major discovery is that clouds have a net cooling effect on global temperatures, a major scientific breakthrough.
With this information, we'll be able to better predict ocean warming, ice melt, crop growth, as well as long-term climatic patterns.
And that's a very major contribution because nobody knew what that was before. And we find, fundamentally, we find that clouds cool the Earth a lot more than was believed before.
As NASA has continued its efforts in space, scientists as late as a decade ago were only beginning to understand the Earth's atmosphere, oceans, and continents, and the complicated process to protect it from all dangerous pollutants. Langley's Atmospheric Sciences Division researchers are among those in the vanguard of sophisticated environmental research.
We're trying to attack global scale problems that nobody else really can attack without space technology.
Langley's atmospheric researchers are using a complex combination of tools like lasers, telescopes, satellite-based gauges, and sensors on airplanes, and enormous computer software systems to analyze all the data. Langley's environmental space program, referred to as Mission to Planet Earth, has become a major research thrust at the center. The goal is to preserve the Earth's delicate ecological balance and prevent an environmental calamity that would have a disastrous effect on the entire world. Every year, thousands of acres of Southern California forests are wiped out by wildfires. Though this particular fire in the San Gabriel Mountains was a controlled burn, it enabled Langley researchers to study the impact of natural fires on our environment. Of primary concern is the effect of large-scale burning on our atmosphere. It's part of a major Langley effort to examine how humans have modified the atmosphere that nourishes life on Earth. Will man's destruction of vegetation and trees by burning have catastrophic consequences for this and succeeding generations? To answer such questions, teams of Langley scientists have traveled all over the world to investigate the types and amounts of gases produced by man-made burning of grass, vegetation, and trees.
Most of the burning in the developing countries in Africa, South America, Asia is human-initiated. Perhaps 90% of it is human-initiated. 50 years ago, we didn't have this amount of burning. The burning going on in the world is a major source of carbon dioxide and other greenhouse gases. Our feeling is the bulk of this burning can be eliminated over the next decade if the leaders of the world realize its impact on the global environment and put into effect legislation and rules to curtail this burning.
In an effort to give educators and students across the country a better understanding of how each of us affects the future of this planet, NASA Langley has conceived the Mission Earthbound teleconference series.
When you start talking about air pollution, and you start talking about the thinning of the ozone layer and what may happen to the overall climate of our planet, then it starts having real meaning for people. We need to give students the tools to learn how to identify the problem, how to start tackling the problem, and then always be creative about how they're going to come up with any kind of solution at all. And that's what we need everybody in our entire country to do, and across the world as well.
Ozone is an invisible upper atmospheric gas that protects all forms of life on Earth from most of the sun's damaging radiation. Radiation that can cause skin cancer, eye damage, and suppression of the immune system. The harvesting of fish and plant life are also affected. A vast amount of aquatic life has its beginnings in the oceans near Antarctica. NASA satellites have discovered a trend in ozone change. Each spring over Antarctica, a hole in the ozone develops, and it has been getting larger year by year. To date, as much as 50 to 60% of the ozone in this area has been lost. Ozone depletion has captured headlines and generated intense scientific effort. Langley researchers have worked with colleagues all over the world to assist in plotting ozone hole fluctuations. Indeed, a Langley study was the first to explain the mechanism by which ozone depletion is intensified. Ozone research is important to the development of the next generation high-speed civil transport.
We do believe we can build a supersonic transport that will have no effect on the ozone layer.
An important part of NASA's mission to planet Earth and its ozone research is the Halogen Occultation Experiment, or HALO, deployed by the Space Shuttle in 1991. Its overall goal is to provide global-scale data on temperature, ozone, and other key trace gases needed to study and better understand the middle atmosphere.
What the HALO experiment is definitely showing us is that the Antarctic ozone hole is leaky, and those effects do spread to the rest of the hemisphere.
Atmospheric science is beginning to enter its own. NASA's vast capabilities are fueling further research into the complicated interaction between the atmosphere and Earth's oceans. Studies such as those conducted by Langley will help policymakers arrive at undoubtedly tough decisions how to preserve our environment into the next century. Next, bringing space technology down to Earth. The America's Cup, a source of American pride in the win by Dennis Conner. Many Cup enthusiasts felt that the loss of the race 4 years earlier to the Australians was caused by a failure to keep up with the latest technology. In an effort to make Stars and Stripes the fastest boat in the field, Connor's design team elected to make use of a new drag technology called riblets, developed by NASA's Langley Research Center and manufactured by 3M. The idea for riblets came out of research to modify airplanes so that they move through the air with less resistance. The same researchers also found that some sharks have riblet-like skin that allows them to glide effortlessly through the water.
We noted from some Russian literature that certain sharks have a structure, a skin structure, very similar to a riblet structure. You look at these things under a microscope, they're tiny V-shaped grooves aligned with the flow of the right scale according to our wind tunnel experiments to reduce drag. Only the fast sharks have these, the slow sharks do not.
It was Langley engineer Mike Walsh who originated research on riblets. Test samples of the riblet film have been flown by Boeing and a NASA Learjet to confirm its efficiency, believed to reduce skin friction by 6 to 8%. That translates directly into savings for the airline industry.
We estimate the savings for the U.S. commercial airline fleet at roughly $300 million per year.
The riblet material could also be used as a protective coating for airplanes and many other applications, from natural gas pipelines to submarines and race cars. Langley's transfer of riblet technology is a part of NASA's highly successful effort to spin off its aerospace research to the private sector. Over the last 30 years, NASA's Technology Utilization Program has spun off 20 to 30,000 products and processes for everyday living, estimated to be worth well over $22 billion to the economy. When driving down the highway, few motorists across the nation and around the world realize that the road surfaces they drive on have been made safer by technology developed at the Langley Research Center. Langley's program to reduce hydroplaning, the loss of traction on wet pavement, was intended originally to increase airplane traction and reduce braking distance. Langley researchers discovered that cutting thin grooves into the pavement helped tires maintain their traction. Safety grooving has since been adopted for use on hundreds of airport runways around the world. Every state in the U.S. and many countries abroad are also using safety grooving on highways and roads. The process has also been applied to pedestrian walkways, ramps and steps, food processing plants, and cattle holding bins. It's been said that safety grooving may be helping more people and saving more lives than anything NASA has ever done.
This is really not a new mission for Langley. Langley's been in the mission of developing new technology, new ideas, new scientific innovations, and transferring those to industry in a timely manner. We've been doing that for 75 years.
Another Langley spin-off is helping burn victims with ultrasound. Originally used to detect structural flaws in aircraft, this technology is now enhancing the treatment of fire-related injuries. Each year, 2 million Americans suffer serious burns. A large number of them require hospitalization, and about 10,000 to 12,000 die from the injuries. The costs of such treatment run several $100 million a year. Ultrasound technology used in Langley's aeronautics research has been modified to make rapid, accurate assessments of burn thickness.
The faster we can make that assessment, the easier it is going to be in terms of the healing process.
This procedure is enabling doctors to distinguish between a second-degree burn that may heal naturally and a third-degree burn, which requires surgical skin grafting. Comparing this ultrasound technique with other medical procedures, Langley's Dr. John Cantrell.
We have been exactly on the money 100% of the time.
Stevie Roper of Waynesville, North Carolina, was born with a very rare physical condition. Lacking sweat glands, his body has no natural way to cool itself. Too much physical exertion or even limited activity on hot days could have been tragic for him. Until recently. Thanks to his family discovering Langley's technology spin-off office, Stevie now has a way to beat the heat. A liquid-cooled outfit with a pump and heat exchanger. It cools and recycles fluid through a vest and hat, a system similar to that used in astronaut spacesuits. Stevie can wear the outfit while exercising or just occasionally to cool down. Liquid-cooled garments using the NASA technology are also being used by firefighters, pilots, and race car drivers. Thanks to the concern of a diverse group of people and the manufacturer, Stevie got his cool suit. Before he had the suit, Stevie was constantly needing to get drinks or applying cold towels. Now, if he gets too hot, he simply puts on the suit and goes on working. He's also far less susceptible to respiratory problems like bronchitis and pneumonia. NASA's effort to transfer cool suit technology has been so successful that Stevie's aunt has started a national foundation. The group hopes to bring this same NASA technology to the other 400 children in the country with Stevie's condition. Sports utility vehicle enthusiasts stand to benefit from another Langley spinoff, a tough new space-tested carbon-carbon composite. Pistons in high-performance engines made of this tough, heat-resistant material developed for aerospace applications may someday be the standard replacement for aluminum pistons. Among its advantages, carbon-carbon composite material has greater strength and stiffness than aluminum and maintains these properties at temperatures at 2,500 degrees Fahrenheit. NASA Langley researchers believe that an engine equipped with carbon-carbon pistons could operate at higher temperatures without piston failure, add to engine life, and help in meeting emission standards. Langley's composite materials research has also found successful application in the first lightning-protected general aviation aircraft made of composite materials. The aircraft, built by Stoddard Hamilton with the high-strength, lightweight material, was adapted from Langley's Storm Hazards program. Composites developed by Langley for aerospace purposes are also proving to be suitable for healthcare products.
Generally speaking, the advanced composites allow a 5 or 6 to 1 reduction in weight, and at the same time they give you a 2 to 3 advantage in strength, which makes them ideal candidates for biomedical applications.
Langley engineers have made a number of biomedical devices, including a wheelchair that's half the weight of a conventional wheelchair, a 1-pound long leg brace, 2 pounds lighter than its steel counterpart, and a 4-ounce face protection mask that children really will wear, 9 times as light and much more comfortable than a regular mask. Next, is continuing investment in space technology worth the price? In this period of government belt-tightening, some critics of NASA wonder if America can or should afford the big-ticket programs that go along with aerospace research.
I think the criticism should be aimed at us. Quite honestly and frankly, we've done a pretty poor job of communicating with the public and with the Congress the benefits of the program that NASA conducts. And this has led to a lot of misconceptions, but it's our own fault.
In a recent NASA town meeting, people were asked to estimate the size of the NASA budget.
A majority of people thought we were of the same size as the Department of Defense. We're less than 5% of the Department of Defense budget at that time. If we can't demonstrate a reason and a positive return, there's no justification in continuing our program.
Those who question the economic value of human activity in space probably don't understand the way modern society has been transformed by developments that came out of our space program.
We intend to work very hard at moving technologies not only into aeronautics and space, but also into other areas of the commercial sector. And we think we'll make an impact on the U.S. economy.
The fundamental to Langley's work is developing a better understanding of the technological needs of the next generation and to create the new materials, the new sensors, the new equipment, the new systems that are required to take advantage of advances in science and technology. If we don't do it, our global competitors will, and they will, as a consequence of that, take over large shares of the global market, which is important to our economic growth. Let's put it in a little broader perspective. Human beings in the workforce want to feel that they're capable of doing more important, more technically demanding, and more rewarding kinds of work. It's the researchers who develop the new technology and create the opportunity for markets in these areas that allow the workers of the United States to aspire to continued improvement in their jobs and in the quality of life that results.
That is our role, to be the research leader, to lay the groundwork and enable the future.
The NASA Langley Research Center, enhancing America's competitive edge and quality of life through aerospace technology.
you